Hello, my name is Steve Bowler, and in this video I'm going to be configuring Border Gateway Protocol, or BGP Confederations, and we're just going to take a look at confederations, what they are, and why you would use them. And in the example that we have here, we have a customer router, which is in Autonomous System 100. Then we have the ISP that the customer is connected to, which is in Autonomous System 200. And you can also see here that we have these other autonomous systems that we have assigned, and we're going to talk to you guys about those autonomous systems. Those autonomous systems there are private, or what are known as private autonomous system numbers. Just like you have public and private IP addresses, you have public and private autonomous systems. And they pretty much serve the same purpose. The public autonomous systems are going to be routable, and the private autonomous systems are stripped off once they leave the autonomous system that they are a member of. So these autonomous systems here, 65534, 65535, and 65533, those are our sub-autonomous systems of Autonomous System 200. So these are the confederations within AS200. So to the outside world, if we were at the customer router, what we peer with is, we don't peer with these sub AS numbers. What we peer with is the AS200. And the reason why you use confederations, usually they're found in very large transit autonomous systems like ISP networks and large company networks, and they're used in the same way as route reflectors are. They minimize the number of iBGP peers that you have to have, and they do that by breaking the autonomous system into sub-autonomous systems. So what we're going to do now is, we already have the IP addressing done. What we need to do is configure BGP and see if we can get this all up and running and show you guys how to configure confederation. So first thing, let's go into the customer router and do a router BGP 100, which is the local AS. Under here we're going to have our neighbor command. We're going to peer with 140.0.1.2, which is ISP1R1, and this time we're going to be peering with a physical IP interface there on the serial link, and the remote AS again is not the confederation AS 65535, it's going to be a AS of 200. So that's what it looks like to the outside world. They don't see, the customer routers will not see these sub-autonomous system numbers. And the private range is 64.512 through 65.535. Those are all AS's, those are all designated as private autonomous system numbers. Okay, so we go ahead and put that command in the customer router. Then we're going to put our network statements in for our loopback interfaces. So we'll go ahead and add those in. And what we're going to do next is we're going to leave the customer router as it is. We have it configured for now. Then we're going to go into ISP1 R2. So we're going to start up on the top right. We're going to configure R2 for BGP. So now the way we do this is we go under global config, we do router BGP. Now we're going to put in the sub-autonomous system number, which is our confederation number, which is 65534. And then we're going to also put in our BGP command here, which is called BGP Confederation Identifier. What this command does is it tells the router when it is a member of a confederation and the confederation ID, which in this case is 1200. I'm sorry, in this case is 200. Okay, so our other important BGP Confederation command is BGP Confederation peers, and basically this is just telling the router which member autonomous systems in which this router peers to, which R2 in this case connects to R1, which is AS65535. So we have to put that under there as our confederation peer. So we're going to do BGP Confederation peer 65535, which is currently router 1. So we're on router 2, we're setting our confederation peer for 65535, which is R1's sub-autonomous system number. Then we're going to put in our neighbor statement here. We're going to peer via the physical, which is 192.168.1.1. And under remote AS here, we're going to type in 65535. Okay, so we'll put in our network statement here for our loopback, which is our R2 network. And we'll set up our mask as well with our network there. So now we're going to go on to, let's see here, let's go to ISP1 R3 now, which is on the bottom right. And we'll set up the BGP configuration on this router. ISP router 1 has the most config, so we'll save that for last. So on ISP1 R3, if we go under global config, what we need to do is set up BGP, so we'll do router BGP. Again here, we're going to be using our sub AS, which is 65533. And then under here we're going to put in the same commands as ISP1 R2. We're going to put in our BGP confederation identifier, and that is the overall AS that the outside world sees us as, which is our basically our public AS, which is 200. Again, this command lets the router know that it's part of a confederation, and it lets us know the confederation identifier. So also we're going to put in our BGP Confederation peers command, in which we peer to R1. So we're going to have to put in R1 sub autonomous system number here. In this case is going to be R1's. From R3's perspective, we're just peering to 65535, which is ISP1 R1. So we'll put in BGP Confederation peer 65535 and put enter. Then we'll put in our neighbor statement. Again, we're going to be peering to R1 via physical IP address, which is going to be which is 192.168.2.1. So here we're going to put in our remote AS, which is 65535, which is the subautonomous system number of R1. And then we're going to go ahead and advertise our network via BGP, which is network 3.3.3.3 with a /32 subnet mask. Okay, now what we're going to do is configure the main router here, which is ISP1 R1. So if we go into global configuration mode and then we enable BGP here, we do this by doing router. Actually, this router has multiple peering connections. It has a peering connection to AS100, then it also has peering session to the Confederation members 65534 and 65533. So we need to understand that when we enable BGP, that we're enabling it on the sub-autonomous system number, or in this case we would say, instead of regularly, we would just configure in router BGP for AS200, but when we're using confederations, the confederation identifier goes in place here. So we'll do router BGP 65535, and under here we're going to do the command BGP Confederation identifier, which is again like our public BGP AS number, which is 200, and then here's where we're going to put our BGP Confederation peers. So in our router 1's perspective, we have two peers. We have our peer looks like here we have our peers are going to be ISP1 R3 and ISP1 R2. So we do BGP Confederation peers 65534, which is R2, and then we're also going to be putting here 65533, which is ISP1 router 3's sub-autonomous system number. So now we'll go ahead and hit enter here, and now we have to add our neighbor statements. So we'll do neighbor 192.168.1.2, which is ISP1 R2, and we'll do remote AS of 65534, and then we'll go ahead and change this down here to 192.168.2.2, which is our connection from R1 to R3 down here at the bottom. The remote autonomous system number is 65533. Last but not least, here we're going to put our neighbor statement here to peer to the customer router. In this case, we're going to do neighbor. This is going to be our eBGP connection, our external BGP. So we'll do 140.0.1.1, and then the remote AS here is 100, which is the customer router's AS number. Now BGP peering can take a little while for it to come up, so just be patient and then your BGP adjacencies will come up. So as you can see here, looks like all of our neighbors have come up. If I do a show IP BGP summary, first thing we can see here on router 1 is our customer connection, which is to AS 100, which is up. We also see our two connections through ISP R1 and R2 and R3, and you can see their sub-autonomous system numbers, 65534 and 65533. So if I do a show IP BGP, what we can see here when I do a show IP BGP is that for these two networks that are attached to router 2 and router 3, there's under the path they're showing up in parentheses. And that just shows that these networks are part of this confederation, and that these sub-autonomous system numbers will not be propagated outside of this confederation, which is in AS 200. So if we were to go on to the customer router and do a show IP BGP, you can see that these networks that are inside of autonomous system number 200 do not show these inside sub-autonomous system numbers that we configured for R2 and R3, because they are stripped off when they are sent out to external BGP peers. So you can use private or public autonomous system numbers when you are doing BGP confederations, but best practice is to do private. Now this is known as the AS confederation sequence attribute here. This just shows the member autonomous systems in the AS path. Again, this is not advertised outside the confederation, as we can see here. As we see on customer router, we don't see those sub-autonomous system numbers in the path. We just see the whole autonomous system, which is AS 200. We do not see the sub-autonomous system numbers that we created. Also, this can be used as loop avoidance within the confederation. So if I receive an update, some 65534, from a peer, if I receive this in the AS path, I'm going to drop it within this confederation. So it's used for loop avoidance and also minimize your IBGP full reachability issues. So if we look on ISP1R2, we're seeing what we're not receiving the routes from the customer. Looks like they're not being added into the routing table. So if I do a show IP route, we don't see those networks into the 130 network. Looks like there's a problem maybe with the customer config. Looks like we never created the loopback, so let's go ahead and do an interface loopback 1. Give it the IP address here. Okay, sorry about that. I just had to correct my configuration. I got my loopbacks now present, and they are in the BGP tables on all the routers. Looks like I had a misconfigured loopback interface on the customer router. So now, as you can see on ISP1R2, we aren't seeing these networks being added into our routing table. So if we go on to ISP1R1, we don't have it's showing the next hop as 140. So for the 130 networks here on R2, it's showing a next hop of 140.0.1. So ISP1R2, there's no way it knows how to get to that network right now. So what I need to do is set the next hop on ISP1 to be ISP1R1 and not the link in between. So we'll do that by going into ISP1R1. We'll do router BGP 65535. Again, this is the member autonomous system. So we'll do a neighbor 192.168.1.2, and we'll do next hop self. And then we'll also do that for 2.2, which is our connection to R3. So this should fix our reachability issues that we had on R2 and R3. So if I do a show IP BGP, now we're seeing all the routes being learned and added into the routing table. So they're not just valid, but they are best, and they are showing up in the routing table. If I do a show IP route now on ISP1R2, those routes are being learned via BGP and being propagated into the routing table. So if I try to do a ping here with the target IP of 2.2.2.2, which is the loopback, actually if I do a show IP BGP on the customer router, you can see now that I have all the routes into the routing table. So I should be able to ping them now. If I try to do a source ping with the source, the target is 2.2.2.2, and we're going to do extended commands. Yes, we're going to source it from the loopback 0 interface, which is 130.0.0.1 on the customer router, and now you can see that that ping is successful. So we do have connectivity throughout. So let's go ahead and test router 3 here. If we go to router 3, if we do a show IP BGP, you can see here that that we have all the networks, and they're all been added into the routing table shown by the caret symbol. So if I do a show IP route on R3, you can see here that we are seeing the routes learned. We can also see the AAS confederation sequence in the path. So the network 2.2.2.2 is showing the sequence is 65.535, which is R1, and then 65.534, which is R2. So again, if I go into the customer router and try to ping that, target IP is going to be the loopback on R3. And then I'm going to do a repeat count of 15. We're going to do an extended command yes. We're going to source it from 130.0.1.1. And as you can see here that we have connectivity. So the only thing that we really ran into a problem with is with reachability, next hop reachability. So we just had to add that to ISP1R1 and to let ISP1, R2, and R3 let them know how to get to the external routes. And that next hop attribute of that is preserved throughout the confederation. So that's why we need that changed. So I think that's about it. So what we did was we configured basic BGP confederations. We showed you the attributes and how BGP works with confederations. We showed you guys how to set it up between 3 different routers within the same autonomous system. Then we broke that autonomous system into 3 different sub-ASs. So thanks for watching, and I hope you'll be with me with the next one. Thank you.